Dear students, this video is about the subject CST 203 Logic System Design. It is introduced for semester 3 Computer Science and Engineering students of APJ Abdul Kalam Kerala Technological University under the latest 2019 scheme. In this video, I will explain about the course outcome, assessment pattern for both internal and end semester examination, the mark distribution, the syllabus, and also the textbooks we can refer. So students, if you are looking for technical content, you can simply skip this video and start watching from the second video onwards. Today, we are using many digital systems to store, process, and communicate information in digital form. The digital computer is the best example for such a digital system. The digital system manipulates discrete elements of information. Such discrete elements may be electric impulses, the decimal digits, the letters of an alphabet, arithmetic operators, punctuation marks, or any other set of meaningful symbols. The arrangement of these discrete elements of information represent a quantity of information. Say, for example, the digits 2, 3, and 7. When they are arranged in the order, we get a number 237. The discrete elements are represented in digital system by physical quantities called signals. More precisely, electrical signals such as voltage and current. The present-day electronic digital system have only two discrete values. They are 1 and 0. That is binary system. After completing this course, the students will be able to understand the organization and design of a computer system and understanding how patterns of ones and zeros can be used to store information on computers, including multimedia data. These are the expected course outcome. There are 5 course outcomes. As course outcome 1, it is given that students must understand about number systems, different types of number system, conversion from one number system to another, and all. The K level for the same is K2 level or understand level. As course outcome 2, it's about Boolean algebra, Boolean expressions, and how we can simplify a given Boolean expression. We will also study about how combinational circuits can be designed. K level is K3 or apply. In CO3 or course outcome 3, the discussion is about design of combinational circuits such as adders, code converters, decoders, etc. It's at a K level 3. Then course outcome 4, it is all about the design of sequential circuit such as registers, counters, and shift registers, and the K level is 3. Then the course outcome 5, expect that a student will be able to use algorithm to perform addition, subtraction on binary numbers, BCD numbers, and floating point numbers, and its K level is K2 or understand. The next is assessment pattern. From the slide, it's clear that K level 3 or application level questions will have the highest weightage. That is 45% of the questions will be from apply level. Then comes the understand category with 35% of weightage. Then remember with 20% weightage. The division of percentage of marks is same for both test 1, test 2, and for the final end semester examination. As we all know, the total marks is out of 150. 50 marks for continuous evaluation, and for end semester examination, it's 100 marks, and the time allotted is 3-hour duration. Next is the pattern of continuous evaluation. If you are regular in class and fetch more than 90% of attendance, you will get a marks of 10 marks for the attendance. Then there will be 2 internal examination, and the marks you scored in the internal assessment test will be converted into 25 marks. The next is assignment. If you submit the correct assignment on due time, you will get 15 marks. So next I will explain about the pattern of internal test. 2 internal examination will be there. out of 50 marks. So total 50 plus 50, 100 marks. First serious test shall be conducted after completing the first 2.5 modules. Second serious test will cover the remaining 2.5 modules. There will be two parts, Part A and Part B, for both internal examination. Part A contains 5 questions having 3 marks. Total 5 into 3, 15 marks. The important fact is that all questions are compulsory. Students will not have given any options. Then Part B contains 7 questions, each with 7 marks. Out of these questions, students will given a choice and they have to answer only 5 questions. So 7 into 5, 35 marks from Part B and 15 marks from Part A, total 50 marks. This is the pattern for both first internal exam and second internal exam. Regarding end semester examination pattern, it's also divided into Part A and Part B. Part A contains 10 questions with 2 questions from each module, having 3 marks. And all the questions are compulsory. So 10 into 3, 30 marks. Part B contains 2 questions from each module, of which a student should answer any one. Each question have a maximum of 2 subdivisions and carry 14 marks. So 14 into 15, 70 marks from Part B and 30 marks from Part A. Next is the syllabus. Module 1 is arranged in such a way that students will attain the course outcome 1. So module 1 is all about the discussion of different number systems, to and fro conversion from one number system to another, binary, addition, subtraction, etc. The next is module 2. It's concentrate on Boolean algebra, simplification of Boolean expressions, implementation of Boolean function using basic and universal gates, etc. I'm giving only a quick overview of modules. We will study it in detail in the forthcoming videos. Module 3 is about the combination logic circuit and module 4 is about sequential logic circuit. In module 4, we will study about flip-flops, then different types of flip-flops, then BCD counters, etc. In module 5, the concentration is given to shift registers, arithmetic algorithm, and finally, we will study about ROM, then PLAs, that is programmable logic, etc. Finally, as a textbook, in the syllabus, it is given as M. Morris Mano is the name of the author, and the book written by M. Morris Mano, Digital Logic and Computer Design. Then to study about the architecture of computer system, we can use the book of the same author. Even though in the text, in the syllabus, it is not listed out. The book written by A. Anand Kumar with title Fundamentals of Digital Electronics is an excellent book we can refer. Thank you. From video 2 onwards, we can start the technical discussion.